we're going to graph exponential functions next. And so we're going to start with just an exploration. This is going to be a new set of toolkit functions for us. We're going to add these. This is what a basic exponential function looks like to our toolkit. But remember how we first learned the toolkit functions is we're like, let's make an XY table and graph it and see what it looks like. So that's what we're going to do to start. But then once we know what they look like, we will not be doing that. And we will be remembering those base graphs and using our translations accordingly. So let's pick just a series of maybe -2, -1, 0, 1, 2 for now, maybe even a 3. And plug them into this function y equals 2 to the x. So you should be able to do that without too much issue. I mean, certainly they get easier here. 2 to the third would be 8. But what about 2 to the -2? What is 2 to the -2? Well, that's 1 over 2 squared because the negative kicks it to the bottom. So that would be 1/4. 2 to the -1 would be 1 over 2 to the first, or just 1/2. So as these numbers got more negative, we would just have smaller and smaller positive fractions. Okay, so if I go to graph that, it's going to be pretty hard for me to graph too many of those, but you could probably see, let me try to zoom in just a little as I do this. Right, what's going to happen here is that these are just going to get so close to 0, but not actually ever be 0. So we'll indicate that with this arrow. And then what that means is we're going to have a horizontal asymptote of y equals 0 on the left side. Right. If I graph the rest of these 0, 1, 1, 2, 2, 4, I think I'm going to run out of room. 3, 4, 5, 6, 7. So it would be a little off the charts. So now you can see this growth that we're talking about, this very steep incline for this exponential function. And if it was a base 3 or 4, it would have the same pattern. It just would have gone up even faster the larger that base number is. Okay, so let's do one more example. And this time what I want to do is I want to pick a base that's less than 1. Remember, the bases still always have to be positive, but we could have a base that is less than 1, between 0 and 1. So let's try that. And we're going to do the same sort of, let's just do those x values for now. So anything to the 0 power is 1, 1/3, 1/9 if I square it. What happens if I raise it to a negative power? Remember, what a negative basically does is flip it. So it becomes 3 squared. What about to the -1 power? Flip it, raise it to the first. So if I'm going to graph those, let me try to zoom in again. Again, looks like I gave myself a bigger grid this time. Still 0, 1. Oops. Still 0, 1. And in fact, no matter what my base is, if the exponent is 0, isn't it always going to cross at 1? And then I had -1, 3, -2, 4, 5, 6, 7, 8, 9. So this time that exponential really quick growth is over here on the left side. And on the right side, it's, I mean, I'm not even really getting that accurately. It's approaching, so I have that horizontal asymptote of y equals 0 on the right this time. And basically, it just mirrored it across the y-axis. If you look at the shape of this one, if I mirror that across the y-axis, I get the shape of this one. So changing the base to a number that's between 0 and 1 will give us this pattern instead of this pattern. The difference, if I were to multiply, just as a quick, if I were to multiply that equation by 2, a number in front, and I don't know that I'm going to have space to graph it because of the numbers will be so big, but I would have taken the original y values that we got here, whoops, that we got here. And now if there was a 2 in front, I'm just going to double them, right? Multiply them by 2. So where I had 9, 3, and 1, I'd now have 18, 6, and 2. And where I had 1/3, and what was the other one? 1/9. So you could see that really what that's going to do is just a stretch, similar to what we did before. Like I said, I will not have space to do this, whoops, all of this on this grid, but I can get a few of them in. So 0, 2, so it doubled that 0, 1, -1, 6, 1, 2, 3, 4, 5, 6, and then I'm way off the chart, and then I'm already down, so it stretches, but yet the shape is pretty similar, right? It's just a little bit stretched. So it's kind of just demonstrating to you that the translations we've used in the past do in fact apply to these base graphs. So what we're going to do is we're going to talk about some of these facts for the base graph, and then we will work on using those as new toolkit functions and translating accordingly. So I want you to actually take a second to pause the video and see what you can fill in about the domain, the range, and the y-intercept, at least that much, and then come back. Okay. So if you take a look back at all of the graphs that we've already done, and you just look at the equation, you can see that there is no mathematical issues in terms of plugging values into an exponential equation. So we don't have to worry about restricting the domain or finding numbers that are violating a math rule. Our domain will be all reals. The range, however, is restricted because you cannot raise a positive number to any power and get a negative or 0. So the range is going to be 0 to infinity. And in this case, as long as there's no number in front, if it's just b to the power, if you plug in 0 for the power, then you will get 1. So 0, 1 will always be the y-intercept. Now, if we did do something where we multiplied by another number in front, the b to the x would give you 1. And so when you plugged in 0, you just get a out. So that's kind of reflected here in number 3. You saw instead of a 1, we had a 2 because there was a 2 multiplier out front. So these things are going to be true for all of our exponential functions. And then the 4 and 5 are just talking about the shape. If b is greater than 1, the graph increases from left to right. So you had that shape kind of like this. That is called exponential growth. Whereas if b is between 0 and 1, we had that decreasing shape, left to right. And that's called exponential decay. So you can add these. Oh, one last thought. Sorry about that. The x-axis, or the line y equals 0, is going to be a horizontal asymptote on one end, either the left or the right, depending on what your base is. So you can now use these facts to add y equals b to the x into your list of toolkit functions. Functions that you know what the shape is, and you know and you know how to graph them using translation. So it accidentally, at least on this, hopefully I'll fix it, the notes for you by the time I upload them. But on my video, I had the wrong next page. So we're going to skip to the page that says we can apply all the transformations to these base graphs. because that's what we're talking about. We're now going to work on translating, okay, these base graphs, similar to how we did before, right? So now I'm going to take y equals 2 to the x plus 1 minus 3, and we're going to talk about what its base graph would be, which would be y equals 2 to the x. How that's going to shift. So the plus 1 would make this go left 1, and the minus 3 would make it go down 3. So then I'm going to graph that. Okay. So we know that the 2 to the x, and here's kind of, I'm going to model for you how you want to apply these translations to exponentials. 2 to the x would go through that 0, 1. It would have this horizontal asymptote here. It would go through 1, 2, right? Because 2 to the first. You could probably map just a couple of quick points. This is what 2 to the x looks like. That's my base. So now I'm going to apply left 1, down 3. Well, down means I'm going to shift that horizontal asymptote 1, 2, 3 down. So I'm going to kind of draw in this dashed line, at least on the left side, to indicate that that's where my new asymptote will be. And then left 1 means I'm going to take those 3 points, 1, 2, 3 that I already put in, and I'm going to move them. They would have gone down. 1, 2, 3. But now I'm going to move them left. 1, move that left 1, and move that left 1. So I'm going to get rid of just the down. And now I can draw in my exponential curve. And this would be y equals 2 to the x plus 1 minus 3. So I have graphed it just using a few base pieces of information and then translating. And I can use the picture to answer domain. Well, domain is always the same. How did the range change? Because we shifted it down, now it's not greater than 0, it's greater than -3. So it would be -3 to infinity. And my horizontal asymptote is no longer at y equals 0, it's at y equals -3. I think it helps to draw the picture first and then answer those questions about domain range, etc. Okay, so there's another number 2 here, similar idea. I'd like you to pause and give it a try. Okay, how did it go? So the only difference between the base graph, which would be 1/2 to the x, which I graphed here in red, would be the multiplied by 4, which represents a stretching of the graph by a factor of 4. And the best way to do that is to take the y values you already had, and just multiply them by 4. So if this y value is 1, it needs to move up to 4. If this y value is 2, it needs to move up to 8. This one was 1/2, it needs to move up to 2. Okay. So that's what gave me my graph of the final function here in blue. You'll notice I did not change the horizontal asymptote or the range for that matter, and the domain is always going to be -infinity to infinity. All right, there's one more on the next page, so once again, pause and give it a try. All right, let's take a look. So now my base graph is just 3 to the x, which I have drawn in here, 3 to the x. Since the base is bigger than 1, it's going to have that growth curve. Always my intercept at 0, 1 for the base graph, and then 3, 1 is another easy point to plug in. This negative is going to reflect my graph across the x-axis. So this point will come down here, this point will come down here. But then the +2 is going to make the whole thing go up 2. So when that point moved down here, I move it up 2, and that point moved down here, I move it up 2. I also moved my asymptote up 2, and I could draw in my curve from there. Domain is still the same, but now because it reflected, all my y values are less than this top y value where the asymptote is. So it would be from negative infinity to 2, and my horizontal asymptote is there at 2.